Hello everyone, welcome to section 2 of Athena, and in this section I'm going to talk about workload management. Workload management in Athena is similar to Redshift if you have gone through the WLM session in Redshift, but Redshift is way more sophisticated than Athena because Athena is an ad hoc query analytics on top of data lake, so it is not a data warehouse by itself. So that's why the features in workload management is Athena is very limited. So to start with, of course, the main reason for workload management is workload separation. So let's say you have small ad hoc queries and then you have large analytical queries. You want to run them in separate places. And not only that, you want to, let's say, limit the amount of data that can be scanned because of cost reasons. So that can also be handled using workload management by workload separation. It also provides access control. So when we create something called Workgroup, and which is used to manage workload in Athena, we can provide IAM access to that. And one of the most important things is the capacity management. So we can mention or we can limit the amount of data scanned for a particular work group. We can also provide specific or dedicated compute capacity for a particular workload using workload management. And finally, it can be used for configuration management also. Now, the way we enforce WLM in Athena is using or through work groups. So, what is a work group and what are the various components of work group? Workgroup is essentially used to separate the workloads in Athena. And when we create a work group, of course, we give the work group a name. So typically, whenever we create a work group, it should have a certain name. Then we define the query engine also, whether we want to use Trino, which is Athena SQL, or Spark, which is Apache Spark. So we can run Athena using either Athena SQL, which runs Trino behind the scenes, or we can use Apache Spark also as the query engine. Then we mention IAM authentication. So as I told you that using workgroup or WLM enables us to provide access control also. And as you know, in AWS, most of the AWS services support IAM authentication and authorization. So we can use IAM for authentication and authorization, and we can actually attach IAM policies and roles to a particular workgroup. Then you mentioned the query result location where the query output would be stored. And if you remember, when we started Athena, we also mentioned the same thing without being in a work group. But was it the case? Were we using any work group or not? But typically in a particular work group, we mention the query result location also. And then the data scan limit, which basically limits the maximum amount of data that a query is allowed to scan. And this applies to all the queries in the workgroup, meaning let's say we mention the data scan limit to be 5 terabytes, and let's say there are 100 queries running in that particular workgroup. That 5 terabyte limit would be for all the queries collectively. And if you, let's say, run only one query at a particular time, not concurrent queries, then the 5 terabyte limit would apply to that only one query. So irrespective of the number of queries that you run concurrently or separately in a particular work group, the data scan limit applies to all the queries. And then we can also configure data usage alerts, and we can do that to send alerts if queries in that particular work group scans certain amount of data for a certain amount of time, or basically specified amount of data for a specific period or specified amount of time. Also, workgroup can be specified at query level using the console API or using JDBC ODBC drivers. So I've been using the console, so I'll show you how we can specify workgroup in the console. And when you use Athena APIs, you can mention that I'm sending this query to Athena, and this query should use in this particular workgroup. Similarly, we can mention the same while sending queries using JDBC or ODBC drivers. So you can ask the driver to attach the query to a particular work group only. Then what is query processing capacity? So we can provision dedicated compute resource, and we can attach that to a particular work group so that any queries that run in that work group will use that amount of query processing. And it is essentially handled by the capacity reservations, and it is used to scale workloads when queries need dedicated compute resources. The major use case for query processing capacity is to enable concurrent query runs, meaning if you have a lot of queries running together concurrently using Athena, then we can provide dedicated compute resource for those queries. Now again, when I say concurrent query runs, it's not that there will be hundreds of concurrent connections in Athena, because Athena is used for ad hoc query analysis, and also it is an ad hoc data warehousing system. It's not a typical data warehousing system like Redshift. So the concurrent queries can be tens of queries, not more than that. And we attach the provision capacity or whatever capacity we mention to work groups that we create. And capacity is measured in DPUs or data processing unit. Like in case of Redshift, it is Redshift processing unit, but in Athena, it is DPU. And one DPU is equal to 4 vCPUs and 16 GB of RAM. Meaning if you give, let's say, 2 DPUs, then you are actually giving 8 vCPUs and 32 GB of dedicated capacity for that particular workgroup. There's a soft limit of 1000 DPUs per account per region, meaning that the maximum DPU that you can provision is 1000, which is 4000 vCPUs and approximately 16 terabytes of RAM. But it can be increased by raising a support ticket with AWS. And this is a typical guideline that can be used. So DDLs typically take 4 DPUs, and DMLs can use anywhere between 4 to 124 DPUs, or maybe more than that also, depending on the query that we are running. So if the query is complex, if the data size is large, then that particular query can use more DPUs. And the DPU requirement for a particular query is handled when a query is submitted to Athena, meaning it's not that even before we submit the query, there are certain amount of DPUs that will be attached to that particular query. That's not how it works. The moment we submit the query, as it goes through multiple paths, does a query parsing, creates an explain output or access plan, etc., and then it is executed. So during that process, calculated by Athena, and then that amount of DPU is given to a particular query. And number of DPUs for DMLs depend on the size of data, file format, query complexity, etc. Now let's take an example how capacity consumption works. So let's say we have provisioned 70 DPUs, how those DPUs will be consumed. So as I said, let's say, for example, we have provisioned 70 DPUs. Now how those DPUs would be consumed. Now let's say I run the first SQL, and when the SQL is submitted, Athena sees that it needs 10 DPUs. So 10 DPU would be associated or attached to this particular SQL statement for its execution. Then we have 60 DPUs left. Then let's say we run 2 more SQL statements concurrently. And the requirement is that these 2 SQL statements take 10 DPUs total. So let's say SQL2 takes 6 DPUs and SQL3 takes 4 DPUs. And then we submit a few more SQL statements, let's say 4, 5, 6, and 7, and all of them take, let's say, 30 DPUs. SQL4 and SQL5 takes 10 DPUs each, and 6 and 7 takes 5 DPUs each. Then we are left with 20 DPUs, and let's say SQL8 and 9 take 10 DPUs, and SQL10 takes 10 DPUs. But during the execution, it so happens that this particular SQL or SQL number 10 needs more DPUs. So what would happen in that case? This particular SQL would fail because no more DPUs or processing capacity is available. So when you see that an SQL is failing because of DPU requirements, it means that we need to provision more DPUs for this particular workgroup. And all of these SQL statements are running in the same workgroup. And Even after that, if we submit more SQL statements, let's say 11, 12, and 13, what will happen? All of them would be queued, and that is the queue time that we see when we execute an SQL statement. So there are multiple CloudWatch metrics which can be used to take a look at the DPU consumption. So there's something called DPU allocated. It tells you how much DPU has been associated with a particular work group, and DPU consumed. This is for actively running queries, and it shows us how many DPUs are getting consumed by all the queries that are currently running. This is another matrix. Then one important matrix is DPU count, and it is basically the maximum DPUs consumed by a query once it is complete. So once the query execution is complete, DPU count would tell us what is the maximum number of DPUs that were consumed by the query. Then we have query queue time, which is the wait time of a query for DPUs, which are nothing but capacity or resources. Now, if we see that the query queue time is pretty high, that means we need more DPUs, or we need to provision more DPUs for that particular work group.